Hello, my name is ASKARA, and today I'm going to explain about the integration of rational function by partial fraction. Definition 1. Let x minus r be a linear factor of g of x. Suppose that x minus r to the power of x, the highest power of x minus r, that divided by g of x. Then to this factor, assign the sum of the partial fraction is a1 over x minus a plus a2 over x minus a square plus until a of over x minus a to the power of and let x square plus b of x plus 2 be an enriched divisible quadratic factor of g of x. So there's x square plus b of x plus 2 has no real root. So on, x square plus b of x plus 2 to the power of n is the highest power of this factor that divided by g of x. Then, to this factor, assign the sum of the n partial fraction is b1x plus c1 over x squared plus b of x plus 2 plus b2x plus c2 over x squared plus px plus 2 square plus until bnx plus c of n over x squared plus px plus 2 to the power of n. And 3 says the original fraction of g of f of x over g of x equal to the sum of this partial fraction. Clear the resulting equation of fraction and arrange the term in equation power of x. 4. Equates the coefficient of corresponding power of x and solves the resulting equation of for the undetermined coefficient. Here, take a look at the example number 1. Explain the content by partial fraction. The partial fraction here is 5x minus 13 over x minus 3 times x over 2. We can write it into a over x minus 3 plus b over x minus 2. And then to find the coefficient a, b, c, we need to clear the fraction and get x times a times x minus 2 plus b times x minus 3, and then we get x times a minus b minus 2a minus 3b is equal to 5x minus 13. And then we compare the coefficient, we get a plus b is equal to 5 and minus 2a minus 3b is equal to 13. And then we let equation 1 plus equation 2 pass. We need to multiply it by 2 to get b is equal to 3 and a is equal to 2 by plugging b into the equation 1. And so on, we can write the partial fraction of 5x minus 13 over x minus 3 times x minus 2 is equal to 2 over 3 over x minus 3 plus 3 over x minus 2. Here is the example number 2. Use partial fraction to evaluate integral d of x over 1 minus x squared. The partial fraction decomposition has the form as 1 over x minus x, 1 over 1 minus x squared is equal to a over 1 minus x plus b over 1 plus x. In order to find coefficient a, b, c, we need to clear the fraction and get a times 1 plus x plus b times 1 minus x. And then we get x times a minus b plus a plus b is equal to 1. And then we need to compare the coefficient. We get a minus b is equal to 0 and a plus b is equal to 1. So on, let's the equation 1 plus equation 2, we get 1 over a is equal to 1 over 2 and b is equal to negative 1 over 2 because b and b we cancel out and a is equal to 1 over 2. By plugging a into the equation 1, we get b is equal to negative 1 over 2. So we can rewrite the integral d of x over 1 minus x squared is equal to 1 over 2 integral of 1 over 1 minus x minus 1 over 1 plus x d of x. By doing some integral calculation, we get 1 over 2 logarithm term of 1 minus x minus logarithm term of 1 plus x plus c. Here, the example number 3. Use partial fraction to evaluate the integral of x squared times x squared d of x over x minus 1 times x squared plus 2x plus 1. Here, the partial fraction can decompose as the form that x squared over x minus 1 times x squared plus 2x plus 1 is equal to x over is equal to a over x minus 1 plus b over x plus 1 plus c over x plus 1 squared. And then to find the value a, b, c, we need to clear the fraction, and we get x times x squared plus 1 square plus x times x minus 1 times x plus 1 plus c times x minus 1 is equal to x squared. And then this parenthesis is equal to a squared plus b, a plus b squared. And then we get x squared plus 2x plus 1 plus b times x squared minus 1 plus c by we need to multiply c into this parenthesis. We get c of x minus c is equal to x squared. And then multiply a into the parenthesis, we get x squared ax squared plus 2ax plus a plus b squared minus bx plus a of x minus c. And then we take x squared, we take x squared out, we get a plus b, and then we take x out, and then we get 2a plus c plus so a and minus b minus c has no value of x, so we get a minus b minus c is equal to x squared. And then by comparing the coefficient, we get a plus b is equal to 1, and 2a plus c is equal to 0, and a minus b minus c is equal to 0. So on, let the equation 1 plus the equation 3, we got 2a minus c is equal to 1. And then let the equation 2 minus equation 4, we got minus 2c is equal to 1. Then we got c is equal to negative 1 over 2. So we plug c into this equation, we get a is equal to 1 over 4, and we plug b into the equation 1, we get b is equal to 3 over 4. And so on, we can rewrite the integral of x squared over x minus 1 times x squared plus 2x plus 1 dx is equal to integral of 1 over 4 times x minus 1 plus 3 over 4 times x plus 1 minus 1 over 2 times x plus 1 squared dx. And then by doing some integral calculation, we get 1 over 4 times logarithm term of x minus 1 plus 3 over 4 times logarithm term of x plus 1 plus 1 over 2 plus 1 over 2 times x plus 1 plus c. And here is another method that used to calculate the partial fraction. It's called Harvey-Sine method. Here the definition is 1. Write the function with g of x factorial. So as you can see here, we get f of x divided by g of x is equal to f of x over x minus L1 times x minus R1 times x minus R2 times until x minus R of n. To cover the factor of x minus L minus R of e of g of x one at a time, each time replace all the uncovered x by the number of R of e. That this is giving a number a of e for each root R of e. Here is the formula that you can see. A1 is equal to f of R1 over R1 minus R2 multiply until R1 minus R of n. And A2 we get f of R2 over R of 2 minus R of 1 times R of 2 minus R of 3 times until R of 2 minus R of n. So on until the A of n is equal to f of n over R of n minus R of 1 times R of n minus R of 2 times until R of n minus R of n minus 1. 3. Write the partial fraction expansion of f of x over g of x is equal to a1 over x minus L1 plus minus R1 plus a2 over x minus R2 plus until a of n minus over x minus R of n. So the example number 2, we use the Harvey-Sine method to evaluate the integral of 2x plus 1 over x squared minus 7x plus 12 d of x. Here is the solution. So the partial fraction here is 2x plus 1 and then divided by x squared minus 7x plus 12. So we can write it in this form. In in this form, and also we can write it as a over x minus 4 plus b over x minus 3. And then by clearing the fraction, we get a times x minus 3 plus b times x minus 4 is equal to 2 of x plus 1. Also, by covering this part, we get x is equal to 4, and this part is x is equal to 3. And so on. If we in order to find a, we need to cover x over 4. So we plug it into this partial function here, but cover x minus 4, because if you plug x equal e equal 4 in here, it will be 0. So we need to cover x minus 4, and we get 2 times 4 plus 1 over 3 minus over 4 minus 3. There will be 9. So on. If x is equal to 3, we need to cover this x minus 3. If we plug x is equal to 3 to here, this will be equal to 0. So we cannot plug it in here. So by plugging x into 2x, 2 times x plus 1 over 3 minus 4 is equal to negative 7. Then we got 2x plus integral 2x plus 1 over x squared minus 7x plus 12 d over x is equal to integral of 9 over x minus 4 minus 7 over x minus 3 d over x. By doing some integration, we got 9 times logarithm of x minus 4 plus 7 logarithm of x minus 3 plus c. And example number 5, use Harvey-Sine method to evaluate the integral of x plus 4 over x squared plus 5 minus 6 d of x. The partial fraction here is for x plus 4 over x squared plus 5x minus 6 is equal. We can write it in this form. Also, we can write it in this form. And then we got write it in this form. We get 4 plus x plus 4 over x minus 1 times x plus 6 is equal to a over x minus 1 plus b over x plus 6. And then we clear the fraction. We get a times x plus 6 plus b times x minus 1 is equal to x plus 4. So on. Here, if we cover this part, x is equal to 1. And here, if we cover this part, x is equal to minus 6. And then, if we plug, if x is equal to 1, we plug it in this partial fraction by covering x minus 1. If we plug x is equal to 1 here, there will be 0, so we cannot plug in it. So, the a will be equal to 1 here, plus 4 over 1 here, plus x is equal to 5 over 7, and x equal to 6. We cover this part. We plus 6 into negative 6 into here, we get minus 6 plus 4 over minus 6 minus 1 is equal to 2 over 7. And then we got the integral of x plus 4 over x squared plus 5x minus 6 d of x. We can rewrite it into this form: 5 over 7 times x minus 1 plus 2 over 7 times x plus 6 d of x, so on. By doing some integral calculation, we get 5 over 7 logarithm of x minus 1 plus 2 plus 2 over 7 logarithm of x plus 6 plus c. So this will be the last example for this video. Thank you for watching, and I hope you enjoyed this video. Goodbye.